Welcome back. In this lecture, we're going to show you how you can use OpenCV to connect to a USB camera or your built-in laptop camera. Then we'll also show you how you can write a video stream to a file. Let's get started by opening up JupyterLab. Okay, here I have a new notebook in JupyterLab. Something that's really important to note is when you're actually reading in video data, it's important that you don't have multiple notebooks and multiple kernels trying to read in from a video stream file. That will start messing up the way OpenCV connects with the USB cameras because they'll start conflicting with each other. So a really good thing to do is open up this file viewer and make sure that you only have one kernel and one notebook running whenever you're working with camera and video data. And you can tell if something's running if you see a green little dot next to the notebook. So notice these other three notebooks that I have here, their kernels are shut down, and you can always right click and shut down kernels yourself manually just in case. But I only have one notebook right now called Lecture Notebook, and it's the only kernel that's running. So whenever you're dealing with video files, you want to make sure you only have one kernel running. Otherwise, you'll get kind of a weird error that's really hard to interpret. So I found out that the hard way, but let's go ahead and continue. We're going to start off by showing you how you can connect a USB camera to OpenCV. We're going to import CV2. And the way we actually connect to a camera is really simple. It's just a simple command, and you assign some variable. Often you just call it capture or cap for short. And you set that equal to CV2 dot, and then the command is video capture. And you notice there's a video writer there. We'll be using that later to write a video stream to a file. But we're going to say video capture, and then you just pass in 0, and that's going to grab your default camera. So we're going to grab the default camera right now. And oftentimes, you're going to want to grab the width and height of the actual capture. That way you can begin to manipulate the video image. And the way we do that is we'll say width, and we're going to say capture.get or cap.get, whatever you happen to call this variable right here from the video capture. We'll say cap.get, and then we say cv2 dot, and then in all caps, cap, prop, and you can hit tab here to start auto-completing this. But the one we're going to look for is frame. And you can grab things like the frame rate, the frame count, but we're just looking here for width and height. So we'll grab that one for the width. And then we'll say height is pretty much the exact same thing, except instead of width, it's going to be height. So I'm going to copy and paste that. And then we'll say height there. Now, something to note is this actually returns back a floating point number. So if you're capturing in 1080p, for instance, it'll return something back like 1080.0. And usually you actually want this to be an integer, especially when you're working with it with OpenCV for maybe calculating the halfway point of your video. And we'll see some examples of that later on. So often you're going to just cast this as an integer or really transform it to an integer. So you'll see this quite often where you just say int to transform this from a float like 1080.0 to just 1080 as an integer. So that allows us to capture the width and height. Keep in mind, we're not going to do this every single time, but I do want to show it to you now. So that's the width and height. And then what we're going to do is we're going to display the image. So we'll say while true, and we're going to say ret, comma, frame, and this is known as tuple unpacking. And we'll say cap.read. So what this command actually does is you can think of the thing that's being returned back by video capture as just a series of images, because all a frame is just a single image, and all a video is just continually updating the image. And what we can do is we can use a lot of the commands that we used before with image files, except just treat them on a single frame and then continually update over and over again on that frame. And what happens is we're going to be able to use cap.read to grab the frame, and it returns back a tuple, which is why we're doing tuple unpacking here. We're going to be using this frame object to kind of manipulate and show. And let's actually show you how you could convert a frame into grayscale. We'll say gray is equal to cv2.cvt color, just as we've done before with images. We take that frame as if it was a single image, which it basically is, and then say cv2.color underscore bgr to gray. And then we'll display that image the exact same way we displayed images before by just saying cv2.imshow frame gray. Keep in mind, if you're on Mac OS or Linux, you may need to actually run this as a separate Python script. And then finally, we're going to wait until someone hits the escape key to stop showing this. We'll say if cv2.waitKey1, so we wait 1 millisecond, and 0xff is equal to, and you can do 27 if you want the escape key, but something else we can do is say ORD for ordinal, and then pass in the string of the lowercase letter you want. So this basically says until they've pressed Q, and then we'll go ahead and break out of that. And then what's important to do here is typically what we've been doing is we say destroy all windows. But before that, we want to make sure that we actually stop capturing the video. So often you'll also see this line, cap.release. Okay, so that's all we need to actually capture video stream file. Keep in mind, right now we're not actually saving anything. We're just continually capturing the image. Again, we're just saying CV2 video capture, pass in a 0 to capture the default webcam that's connected to your computer. And then sometimes you may want the width and height in order to work with the video in some further manner. So you can capture that here. We're not actually doing anything with it, so we could technically comment this out and it wouldn't change anything. Later on, we'll actually use this data. And then we say while true. So in this true while loop, it's going to continue on forever until we say go ahead and press Q in order to break this out. And we're going to read off the camera. It returns back this tuple. Right now, we're only using the frame, essentially just the single images that the video capture is returning. And then you can basically do whatever you want to that frame, just like you would with an image. So that's what this is showing. The image is coming in as color, and I'm going to convert it to grayscale. And then I show it using ImShow, just like I would for a normal image. Let's go ahead and run this and see if we can successfully see myself on the camera. So I'm going to hit run there, and there I am. Okay, so I have my webcam kind of pointed at me, and if I want to quit this, I can just hit Q, and I hit it out. Okay, so we showed you how to convert the image to grayscale, but let's imagine you just wanted to read in the raw color image. All you need to do is comment out this gray, and then instead of passing gray here, we'll just pass in the direct frame. So we'll say frame. And this is just going to grab exactly what the camera is reading and then show it in a window called frame. Let's run this. And there you have me. Now I should be in full color. Good to see you guys there. Okay, let me press Q to escape. All right, we just showed you how you can directly stream the video, but we haven't actually saved that video file anywhere. There's going to be 3 important lines to add in to actually write your stream to a video file. The first one is to actually create a writer object. I'll say writer as my variable is equal to cv2.videowriter. And this video writer is going to take a couple of parameters. The first one is the actual file and file path that you want to save this to. So here, I'm just going to say my supervideo.mp4. And if you want to save this file somewhere else, you can just write in the full file path. So if you want to save it in some deeper folder like data, you can do something like that and just keep going. Keep in mind, if you try to put in a file path with folders that don't exist, you'll get an error. If you just pass in the MP4, it's going to save it to the same location that this notebook or your script is currently running. If you're running this in a notebook and you're curious, well, where am I actually located on my computer? You can always just scroll down to a new cell, type PWD, do Shift-Enter, and it'll tell you where you're currently located. So underneath my downloads folder, I'm going to end up saving this mysupervideo.mp4. I recommend you give it some sort of unique name, that way you don't accidentally write over some previous data. Okay. Now, this next parameter is probably one of the most important ones to pay attention to. It's going to be cv2.videowriter_, and you can tab autocomplete this, 4cc. So this is the actual video codec that you're going to be using to write this MP4 file. And what's really important about this particular parameter is that it's going to be different depending on your operating system. So I'm going to go ahead and show you the link to the documentation tutorial that explains a little bit about the codec you should be choosing, and then I'll kind of clarify what it's actually trying to say. So if you come over here, this is linked in the actual resources for the lecture. There's a 4cc. It's essentially a 4-byte code used to specify the video codec. And the list of all available codes can be found at 4cc.org. And depending on what your actual operating system is, you're going to be choosing different codecs. So if you're on a Ubuntu computer, a Fedora distribution, or on Mac OS, you're going to be using XVID. If you're on Windows, you're going to be using DIVX. Okay, so let's go ahead and check this out. The way you actually write this inside of the 4cc is you say an asterisk, and then as a string, you're going to type in our case, since I'm on a Windows, I'll be referencing here, I'm going to be doing divx. And often this actually works on Ubuntu and OS X, but just in case, you may want to use xvid since it's a little more reliable for Ubuntu and Mac OS computers. But in my case, I'm going to say divix. So just to make it clear, if you're on Windows right now, go with divx inside that string. If you're on Mac OS or Linux, you're probably going to want to go with what they suggested, which is xvid. So that will be xvid. And remember, these are going to go as strings, so you type in an asterisk, and then a single or double quotes, and then asterisks here. Whoops. xvid, single or double quotes. So keep in mind, it's kind of tricky because it's almost the same thing, just the X is at the beginning or the end, depending on your operating system. So this is absolutely key. Otherwise, everything will run successfully, but the file won't get saved. So keep that in mind. Since I'm on Windows, I'll type out divx in here. So that's the codec we're going to be using. The next parameter is how many frames per second you actually want to record at. Depending on what kind of USB camera, you are probably limited in how many frames are actually captured by your USB camera. If you've ever seen a very high fidelity video of something that's shown in slow motion, those kind of specialized cameras capture a lot of frames per second. So they're getting a lot more data per second of film than a typical camera. Now, USB cameras are generally not as good as those high fidelity cameras. So you're probably working with somewhere around like 30 frames per second. And I would recommend you provide a number here somewhere between 20 and 30. And you can actually capture the frames per second here using some of these CV2 capture property. So if you do tab here, it'll actually show you frame count. So that's a nice way to figure out, well, how many frames am I actually getting? So you can go ahead and experiment with that, but typically most USB cameras capturing around 30 frames per second, depending on how good your camera is. So just to keep it safe, I recommend providing a number somewhere between 20 and 30. And remember, the more frames per second you capture, the larger this data file is going to be. And then lastly, we want to provide the width and height. Luckily, we actually already captured that information, width and height. So let's provide that as well. We'll say width and height. Okay, so that's our video writer object. Remember to check the documentation. One of the key points of confusion, often with beginners, is this line right here. So you want to make sure you provide the right code there. Now that we have our writer object created, we just need to scroll down to this while true loop. And once we're actually reading in the frame, we're going to write that frame to this MP4 file. So usually you're going to perform whatever operations you want. So operations can be like drawing on the actual video, which we'll go over later. And then once you're done with all the operations like object detection or object tracking, then it's time to actually write this. So we'll say writer.write, and you're going to write that frame. So basically, frame by frame, you're going to be continually adding to this MP4. And then once you're finished writing and you've broken out of this while true loop, then once you release the capture, you'll go ahead and also release the writer. All right, so the three main lines we added in is this video writer, writing each frame, and then releasing the writer. So let's try this out. I'm going to run this cell. You should see me pop up here. I'll say 1, 2, 3, hit Q to quit. And then in my files over here, I should now see at some point the MP4 file show up. So there it is, it updated, and now I see my supervideo.mp4. And in fact, I can go to my file viewer on Windows. So let me open up this file viewer. I'll go to downloads here, and right here I can see my super video. I'll double click on it, and now my Windows computer is playing the video I just recorded. So that's all we need to do to actually write our video files. Okay, so that's it for this lecture. If you have any questions, feel free to post to the Q&A forums. Definitely, probably the hardest part here is choosing the right codec. If you're on macOS or Linux, you may want to experiment with this if you get errors using xvid. Okay, we'll see you at the next lecture. Welcome back, everyone. In the previous lecture, we talked about streaming directly from a USB camera, but sometimes you're dealing with video files that already exist. Maybe you downloaded a video from YouTube and then you want to kind of play around with it. So what we can do is use OpenCV with existing video files. Let's check it out by jumping over to a new notebook. All right, here I am at a brand new notebook. Inside of a single cell, I will say import CV2, and then I need the command to actually read in an existing video file. Keep in mind, we actually provided some MP4 files for you. So if you open up this folder and check out data, and begin scrolling down, you should be able to see some MP4s here. So I have a hand move, finger move, video capture, etc. So there's different MP4 files, or if you're able to follow along with the previous lecture, you should also have the video file you created earlier. So I have mysupervideo.mp4. In our case, I'll just open up mysupervideo.mp4 since it's a shorter video. And the way we do this is really similar to the way we captured a stream. We just say CV2, video capture, and last time we provided a 0, which says grab the default webcam. In this case, we just provide the file path to the video we want to actually show. So in our case, it's mysupervideo.mp4 or any video. And often, students sometimes accidentally provide file paths that don't exist. And because OpenCV is pretty flexible, it just returns an empty object. And something to do is say if cap is opened is equal to false. That means that we weren't actually able to open up this file. So in that case, you should print out error file not found. So if you get error file not found, that means that you weren't actually able to open this. Sometimes it's also not able to open it if you use the wrong codec. So again, as we previously mentioned, if you're writing your own file, you have to use the correct codec, whether you're on a Ubuntu, Windows, or macOS computer. OpenCV sometimes is able to write something that looks like a file, but it's not able to open it. So if you for sure know that the file is there, but you're still getting an error when you're trying to open it, you may want to try re-recording it with a different codec. So keep that in mind. All right, so we say if cap is opened, that's equal to false, print error file not found, and I'll also mention here, or wrong codec used. So we have that going for us. Now, if that doesn't trigger an error, then we're ready to actually display. We'll say while cap is opened, meaning while the video is actually playing, we're going to grab the frames just like we would with a normal capture. We'll say is equal to cap read. And if it's actually returning something, meaning the video is still playing, if RET is equal to true, so it's still returning frames, we'll go ahead and show those frames. We'll say CVT or CV2, excuse me, in show frame, and then display that frame. And let's add in some code that we can quit out of this while we're displaying the frames if we want to. We'll say wait key, wait 10 milliseconds, and 0xFF. And depending on what you want, you can set it equal to 27 for escape, or if you want a particular letter, you can do the ordinal of Q, and then we'll say break. Now, this is a pretty short video that we just recorded, but if you're dealing with a really long video, you'll probably want to have the option to escape. That way you don't have to watch the entire thing. And then I'm also going to add an else statement here that says else break. So what is this else break for? Notice that this else is lined up with this if statement, the very first one. And basically what this says is, while the capture is actually working and it's open, go ahead and keep reading the capture while you're still returning something, show the frames, and if you want, you can break out of it. If you're not returning anything, meaning you've already shown all the frames, then break out of this while loop because we're no longer open and we're no longer actually viewing any video. You've already seen the whole thing. So you want to make sure you have that else break there. Outside of the while loop, we're just going to release the capture, and then for good measure, we'll destroy all windows. Okay, so let's check this out. I'm going to play this, and there's the video there. Now, as you probably noticed, the video was played extremely fast, and that's because video capture, when pointed directly at a video, it's not actually really meant to display the video for a human user. It's really just meant to quickly read in every single frame and then do something to it. And that makes sense because the computer can watch the video much faster than a human can. It just needs to look at every single image. And that's good because if we want to eventually write or manipulate videos, we don't have to wait an hour for an hour-long video. Instead, we can just do all our operations and not need to worry about showing it. But if you do want to play back the video at a speed that is understandable to a human, what you need to do is add in 2 extra lines of code. So here, we're going to import the time module that's built into Python. And then every time we show the frame, we want to show it at the same frame rate that it was recorded. Now, in our case, I actually know what the frame rate was because remember, we wrote this with writer at 20 frames per second. So what we're going to do here is say time sleep, and then sleep basically says have a delay of X amount of seconds. So we want it to delay 1 over the frame rate per second, which makes sense because that will then display the frames at the exact same frames per second as we recorded in. So in this case, 20 is going to be whatever your frame rate is. So you can play around with this number depending on what the frame rate for the video is. And you can always capture the frame rate information using the same way we captured width and height information from the previous video. So again, all I'm doing here is I'm importing time, and then I'm delaying how fast I'm showing these frames. This is only going to be useful if you yourself want to view the videos. If you're trying to do an operation on a video and don't have any intention of watching it, you don't want to sleep. Otherwise, it'll take just as much time to do the operations on the video as it does to watch the video, which isn't very efficient. But in our case, we actually want to play back the video at a rate that makes sense to us. So I'm going to run this. And there we go. Now I can see the video running at 20 frames per second. So I'm delaying how fast it's showing the frames. Okay, so again, it can read in the frames much, much faster than a human can see them. If you wanted to show the frames at a particular speed, you just need to have a delay here using the sleep. Okay, if you have any questions on that, feel free to post the Q&A forums. But again, it's just logic here. We're displaying it with a delay of a certain frames per second. So it's 1 second divided by the frames per second. All right, so that's how you can display video files using OpenCV. We'll see you at the next lecture.